All right, so that should help us solve this problem here, invert a binary tree. So, and this is 226, so this goes at the bottom here, pub on LC 0226, invert binary tree. Like that. And then grab that. So in order to do this, what do we need to do? We do need these guys. Let's just copy the whole thing here. I guess I can just leave solution there if I say pub struct solution. I don't think we're going to need that. Let's get rid of that. So this should be able to return a none and build, right? Let's do that. Oh, we do need the tree node. Use create tree node. Yeah. Okay. So how do we want to invert a binary tree? Basically, we need to walk it in reverse order. So we say our right node is equal to the left node and our left node is equal to the right node. And we need to be able to do this. I'm just wondering if we can just do it all in line or if I need to create a separate function to do the inversion. I guess the first thing we need to do is write test. Test ex1, and we can say let tree is equal tree node. It's basically the same code we had from before. So let's just grab that. And then we're going to invert it. So let inversion is equal to invert tree. And then we can assert EQ, inversion. Oh, this is where we need to, convert it back to an array, right? Inversion dot unwrap dot borrow dot into array is equal to, and the inversion is going to be, see, 9764321. 9764321. All right, and that should fail because we're getting back a none. Yeah, we're unwrapping something that shouldn't be a none. Okay, good. Now we just need to invert it. So I think it's just if let some node is equal to root, then we're going to say the right side is equal to invert tree. Oh, we might have to do node.borrow left. Yeah, we might need a second layer of this because we want to pass in a reference to the trees, not a. Let's see if this works. Left is equal to invert tree of node borrow right. And then we're just going to return a tree node, an option, RC new, ref cell new. That's a little crazy. And we're going to create a new tree node here. Tree node of, the value is going to be the current node's val, which is node.val, node borrow val. And then left and the right are just going to be the things that we got. Otherwise, if there is no node, we just return none. Oops, none. Is that going to work? Because this might not work here. Expected one of 7 possible tokens. Oh, because I forgot the colon over here. Yeah, we can't move this. So I think what we're going to have to do is, because we can't change the function signature, is we need to pass in references. So I need to write a separate invert, which takes a reference. A reference to this mess. But returns the whole mess. And then it's just basically this. And then we can pass in references here. And instead of saying invert tree, we say invert. And then up here in invert tree, all we have to do is call invert with a reference to root without the semicolon. And, oh, I called it node. I guess we could call it node. That needs a reference. And that passes. Okay, so that's all we needed to do to invert the tree, is just set the left equal to the right and recurse down. Right, we'll just say the right is going to be equal to the inverted left tree, and left is going to be equal to the inverted right tree, and that just recurses down and figures it all out. Let's do example 2 to make sure we can do a single layer. I don't see why that wouldn't work. ex2. It's basically all of this, except we change the arrays. We're going to start with 2, 3, 1. 2, 1, 3, sorry. And the output is going to be 3, 2, 1. I suppose I could write a piece of code that generates the output like this. Okay, so that passed. I don't know where it is. Here it is. ex2. And then we should just test a null tree, but that should work because it just checks right there. So let's just do that. ex3. So tree node. Let's see if we can do it this way. Node from, oh no, we want to test none. Invert tree none is equal to none. Yes, so that passes. Good. All right, so we should be able to just paste this in now. Yeah, oh yeah, so this is where things get a little wacky because we have this solution thing. I don't know if I can throw extra code in here. Let's find out. So we'll copy that and paste it here. Can I do this? Well, let me do this, is what I'm asking. And then all we have to do, say, is invert root. Will that run? They're judging me. Yeah, that worked. Okay, so let's try submitting that. So you can make little functions that help. It was accepted faster than about half of the other solutions. That's not too bad. All right, let's commit these changes. Git commit -m problem. Oh. Git commit -m problem 226 invert binary tree. Good.